Hi everyone, this is the lab report for Lab 4. Our purpose for this lab is to observe some data of a magnet falling through a tube of aluminum foil and to model the experiment computationally, and at last to compare those two experiments. These are the two fundamental physics principles versus Faraday's law, which models the how change in magnetic fields would induce electromotive force, and Biot-Savart law says how a current induces a magnetic field. And these are the brief preview of my results, my measured dropping time, and my model dropping time. This is my experiment setup. I drop a magnet from the top of the aluminum foil and I record the timestamps. And after that, I calculate the dropping time by calculating the differences. And then I do the same thing for 5 times. The experiment data is as shown. I measured all the lengths before I do all the experiments. So this is a video of me dropping the magnet. I did the whole thing 5 times, and the average of the 5 experiments is 1.03 seconds. This is my glow strip code. I first entered all the measurements, and then I wrote a function for the magnetic field and d flux over dt. And then I finished all the other steps and calculated and got the result for the net force on the magnet. This is my results for the modeling. You can see the modeling time, dropping time is 0.963 seconds, and this is the graph for velocity versus time. So some interpretations of the simulation. First of all, red ring is clockwise and blue ring is counterclockwise. And if we flip the magnet, then it will still receive the same amount of force and it will drop in the same speed and the same motion. But the only difference is that the currents would flow in different directions, in opposite directions. And the third is that my modeling time agrees with my measured dropping time. And the model can be made more accurate by putting more rings onto the stack. So some explanations for my graph. There is basically two forces acting on the bar magnet, the gravitational force and the magnetic force. And at first there is no velocity, therefore there is no magnetic force. And as the speed increases by the gravitational force, there is more and more magnetic force. Therefore, you can see that here the magnetic force increases and they reach a equilibrium and therefore stays at the same velocity. And as it leaves the tube, there is no more less and less magnetic force. Therefore, the velocity increases again. Some additional questions. If the resistivity of the conductor is reduced to 0, then there would be the induced current would be close to infinity, and therefore there would the magnetic force acting on the bar magnet would also reach infinity, and the magnet would flow very, very slowly. The second question is, what if there were holes or slots? Basically, if there were holes or slots, there would be less ring currents because the ring is not a closed wire. So this would basically reduce the amount of ring currents and therefore reduce the amount of magnetic force, and the bar magnet would fall way quicker. That's all for my lab report. Thank you.